Welcome to this special episode of Frequency Matters, the RF Microwave Update series. I'm Pat Hindle, and today I'm talking with Ethan Lin, co-founder and vice president at TMYTEK. Welcome, Ethan.
Hi, Pat. Thank you for having me.
TMYTEK has many millimeter wave technologies, including reconfigurable intelligent surfaces or RIS, and promise to improve the coverage for 5G and 6G systems. This is kind of a newer area of technology, so I wanted to explore with Ethan because you have a lot of offerings in this area. So, can you tell us the importance of RIS technology for advanced millimeter wave communications?
Yeah, sure. Thanks for asking the question. The challenges we are facing with millimeter wave communication have been really the major driving force behind bringing RIS technology to this real world. So RIS evolved from research like meta services or other electromagnetic wave manipulation technologies. And now it offers some really an innovative solution to overcome wave communication challenge. First, RIS is solving millimeter wave propagation problems. So as you know, a millimeter wave signal needs line of sight. So it really get blocked easily by walls, people, rain, and others. So RIS acts like a smart mirror. That mirror create a virtual path. The virtual path for signaling to reach their destination, no matter there's obstacle or something somewhere in between. So this gives us a cost-effective and reliable millimeter wave coverage in challenging urban environments. So I think it's the first part is about overcoming propagation problems. Second, I think it really significantly opening new doors for exciting new applications. So we're seeing amazing potential for high precision sensing and localization in smart city and in smart factories and so on. So that is some area that RIS can work with the millimeter wave communications to benefit its high directive propagation characteristics, yet with good coverage, right? Um, I think but RIS also works beautiful with the massive MIMO system to reduce the number of active antennas. That means to reduce the power consumption. Another benefit is about security. So actually, with the RIS, by design, we can intentionally create or eliminate the coverage in specific area. So we can create the dark zone, or we can illuminate the dark zone by our intention. So actually, but the bottom line is the RIS really transform those uncontrollable wireless channel into fully programmable environment. So that's my bits about how RIS can really benefit to wave coverage.
And so it has to reflect the signal and it has to interact with it. So how do you accomplish low loss reflection, at different angles and different frequencies?
To answer that question, let me explain a little bit of how RIS technology works in a way that is easier to understand. So think of a RIS specifically engineered services. There are multiple thousands or multiple thousands, hundreds of elements as like array. So they are made up of really many massive or semi-passive elements. So what makes it special is that they can overcome traditional limitation of Snell's rule, right? The Snell's rule that governs how light or EM wave reflect over surfaces. So when we are able to manipulate each element, we can tune up the phase of each element. That will determine how EM wave to be reflected from any angle, right? So that's how we call the reconfigurable intelligent services. So when it comes into RIS, there are several options, technology available nowadays, including pin dial, including reactors, LCD, or even MEMS. So each offering different advantage depending on the applications. Let me focus on pin dial for a moment, because that's where our technology was central. So uh, those tiny components, the pin diode, act as a phase shifter in our system. Actually, when we applied forward bias to one element, then that pin diode really essential work like a short circuit. So that means that will give me 180-degree phase shifter. On the other hand, conversely, when you apply reverse bias to an element, then that pin diode will operate like an open circuit, and that will result in a 0-degree phase shift. So that means we are able to manipulate the 1010 of each element and create the patterns that I need to meet the specific incident and the reflection angle. So actually now it's what's the magic happen. When each individual, of course, the reflection element might experience some loss from each element point of view. But whenever we combine all of them, thousands of them in an array configuration, that something remarkable occurs. With n elements, what does this? The n element, then we really can achieve n squared gain. All right, while only increasing a noise by a factor of n. So that means in total, okay, we have been benefited by the signal to noise ratio by a factor of n. That is way larger than the loss in each element. So which translate into a much better performance to overcome our customers' applications. So I think that's an explanation how REASE works and how we overcome the lossy of each element by combining array gain into the concept, into this picture.
That's a great explanation. And TMYTEK has a nice short video covering this technology. So let's take a look at that now.
As we move towards 6G, dynamic RIS is redefining how signals travel. With active control, each RIS element can precisely reflect, steer, or focus millimeter wave signals. Let's take a closer look. We set up a typical L-shaped corner reflection scenario. At the transmitter side, B-Box1 sends RF signals. The UD-Box 5G handles up conversion to millimeter wave, while the NIPXI VST system generates the signal. The signal hits the RIS, which is now in a 2x2 array mode, extending both range and coverage. It then reflects toward B-Box light, down converted again by the UD-Box 5G, and analyzed by the PXI VST. Here, we can clearly see performance through real-time data. With WebTLK, we can combine RIS tiles into larger arrays based on distance and easily adjust the reflection angle. Now we switch to a 1x2 array. This shows how different setups impact signal behavior and how flexible dynamic RIS can be. RIS offers hybrid band advantages, enabling seamless switching between FR1 and FR2 bands. With just one controller, users can easily reconfigure the system for different frequency ranges. Dynamic RIS unlocks a software-defined environment, enabling more efficient and controllable millimeter wave communication.
So Ethan, can you tell us about some of the various products and specs for TMYTEK's technology?
Yeah, sure. At TMYTEK, we're excited to offer cutting-edge solid-state RIS product. By the end of this quarter, we're going to roll out all of our 3 distinct frequency bands available for our customer. Let me walk through some highlights of specification and of our product lineup. So first, our product covers diverse frequency ranges. We have 3 bands. First, we cover C-band, the central by 3.5 gigahertz, and another model we cover the central by 4.7 gigahertz. That is for FR1, especially useful for private network. All way up to 28 gigahertz version with quite a wide bandwidth, 26 to 30 gigahertz with our millimeter wave FR2 solution. Regarding polarization, currently we offer all the linear polarization and the the angle of incidence and the reflection are both plus and minus 60 degrees. And another important the factor is that when it comes to array size, the 3.5 gigahertz RIS features with a 10 by 10, which is 100 elements. When it comes to 4.7 gigahertz, the steps up to 16 by 16, which is 256 elements. And our flagship 20 gigahertz RIS boosts up to pretty impressive. It's 1K array, 1,024 elements. So even cooler is that we design our RIS to be able to tile up. Multiple of RIS panel can be put together up to 4, 1, 2, 3, 4. That will create larger services to be covered or to be used to offer higher gain. So tile up is definitely another important feature in our product portfolio. Performance, of course, or the RCS gain, which is one of very important figure from merit used to measure how RIS is working. So the RCS gain for our 3.5 gigahertz it's around 38 dB. For 4.7, we offer is about 45 dB. For millimeter wave, this 1K array, so that it's really significant. It's 56 dB. In especially in some incident and reflection angle. Of course, power consumption, where in our technology we offer the power consumption from 5 watts to 20 watts. So we are still trying our best to minimize and reduce that further in future model. A ready-to-use GUI, as you can see from the video, and a comprehensive API set is another highlight point that I would like to share with you. So beyond those product features, make me believe we have pretty much developed a comprehensive product. Along with our millimeter wave wireless testbed, we do support communication researchers, network engineers, or MNOs, deployment technicians in their work.
Yeah, that's a great variety of products, and I love that they're modular. That really goes a long ways in configuring a system. So how do you see this technology evolving as we head into 6G?
All right, so I think that's really my favorite question, because we are, in TMYTEK, we are always looking to the future. So let me share my vision for how RIS technology will evolve as we move towards 6G. So first, frequency evolution. Of course, now we do have FR1, FR2, FR3. TMYTEK, we offer all these bands. In the future, in 6G, but what I can see is RIS technology will expand into sub-terahertz in the future, not now, in the future, and even step into terahertz or even optical domains. That means we are able to support those incredible data rates as 6G promises. So another I'm particularly excited about is another aspect. It's about intelligence. So today the RIS system requires manual configuration, right? We still need to API, or we need a base station to tell how RIS you should config, right? But how about in 6G? We're talking about a truly smart services that can adapt in real time. Imagine one RIS panel, they use AI, so to constantly optimize the configuration based on users' movements, network traffic patterns, environment changes, and many so on. So all happening automatically without human intervention. So that is particularly the area we are so excited about. Another game changing is, as I mentioned in the first question, it's about how multifunctionality of RIS can be. Now, of course, to enhance the coverage for communication would be the very first and number one application. Now I'm talking about localization and sensing. So current technology is focusing on connectivity, but in 6G, the same panel can simultaneously enhance not only connection, right? Precisely locate objects with a lower power consumption device like RIS. Okay, so there are so many scenarios that I can imagine. So with this the localization or sensing capability, what I can imagine is a very useful IoT network or for smart city and so on. So my last sharing is about it's about a physical integration into the environment. Now in our device is still quite visible, right? But now there are so many different materials are developed to be printed on top of glass. So that means in the future, there are more and more RIS or such kind of services will be integrated into the environment, like the glasses or the building, so make it invisible. So as you can see, there with those innovation and technology advanced, more exciting application is waiting up us in the future. So that's some my opinion, some of my opinions.
Well, thank you very much, Ethan, for talking with me today about RIS technology. You guys have really done a great job in this area and look forward to following your developments as you go along. To our audience, you can find more videos at videos.mygravejournal.com. Thanks for watching.